All right, so now we're going to work on solving inequalities that have variables on both sides of the inequality symbol. So first, we want to try to get the x's on the same side. I'm going to subtract 2x to move the x's towards the left. So I will have 6x minus 2x is 4x. I still have minus 5. It's still less than and 11. All right, so now I'm trying to isolate the variable, which means get x by itself. So I'm going to add 5. So I have 4x is less than 11 plus 5 is 16. Now I will divide by 4. I don't flip the sign because I was dividing by a positive number. So my answer is x is less than 4. All right, I'm going to go ahead and have you try example 2b. Solve the inequality for x. All right, so first I subtracted 3x to move it to the other side, trying to get the x's on the same side. It doesn't matter which side, just the same side. So 5x minus 3x is 2x. I still have minus 12. The symbol hasn't changed. Oops, that 3x simplified out because 3x minus 3x is 0, but I still have a negative 4. So now I'm going to add 12. So I get 2x is less than or equal to negative 4 plus 12 is 8. Now I'm going to divide by 2. So x is less than or equal to 4. All right, let's look at example 3a. 3a and 3b, the only difference is not only do they have variables on both sides, but they also have some distribution. So on the right-hand side, if you distribute the 4, what will you get? All right, so if you distribute the 4, you're going to get 8b plus 12. You still have on this side 8b plus 3. So now let's go ahead and solve. The first thing we need to do is get the variables to the same side. So I'm going to subtract 8b to move it towards the left. When that happens, 8b minus 8b is 0, so it simplifies out. Same thing on this side. 8b minus 8b is 0, so it just leaves the 12. So now, this is a weird solution because the variable's simplified out. So what you need to ask yourself is the inequality true? So is 3 greater than 12? And you're going to say no, 3 is not bigger than 12. So this is no solution. So it's very similar to when we had special cases in equalities. We were like, oh, is 3 equal to 12? And we'd say no solution. So you're just saying, is it true? And if it is, we're going to go ahead and at that graphic organizer, you can see we're going to put all real numbers. And if it's not, we're going to put no solution. All right, let's try another one. Let's distribute the negative 4. I'm going to get negative 12n, and negative 4 times negative 1 is positive 4. Now, I do not have to flip the sign because I didn't multiply both sides times negative 4. All I did was distribute. And when I distribute, that is not multiplying both sides times a negative number, so you do not flip the sign. All right, so let's get the n's to the same side. I'm going to add 12n so that I move it to the left. So once again, weird things happen. The variables simplify out, and I'm left with 4 is greater than 3.2. So you ask yourself, is that true? Is 4 greater than 3.2? Yes, it is. So you put all real numbers, or the symbol for all real numbers is this capital R with 2 legs. That's what the symbol is for all real numbers if you prefer to do that. So let's fill out our graphic organizer. If you get one solution, you'll get something like b is greater than 5, or x is less than or equal to 3.8, something with a variable. If you get no solution, it will be false, meaning 3 is less than 12. Oh, I'm sorry, that is true. So it will be false, meaning 3 is greater than 12. That's not true. 3 is not bigger than 12. Or 5 is less than or equal to 1. That's not true. 5 is not smaller or equal to 1. All real numbers, keep in mind, is that symbol with the double legs on the R, and that's when it's true. So like 3 is smaller than 12. That's true. Or 5 is less than or equal to 5. That's true because although it's not smaller, it is equal. All right, and we will work on this a little more in class.